Welcome to Owie and Sandy Math Along. I'm Sandy.
And I'm Owie.
Hello, this is number 1 on AppleRouth's SohCahToa lesson. And number 1, of course, as always, I've made mine a little bit different. You have a right triangle with right angle B. If cosine A is 3/4, what is sine C? So if you can visualize this without drawing a picture, then go for it. I always like to draw a picture. Now, it might be a little intimidating because they're like, well, we have a triangle. I don't know what it looks like. But they tell us it's a right triangle. So we know we have a right angle. And you can just draw in a generic, okay, right triangle. They do tell us our right angle is B, okay? And we know that the overall triangle is called ABC. So it doesn't matter, and I know this is hard for some of you guys, it does not matter if you write ABC or if you write ABC, okay? You do what you feel the most comfortable with. I'm just gonna do ABC because it kind of looks like it's in order when you do that, but it's a personal preference, okay? Now, the important part is they say cosine of A. So whether you put your A here or there, make sure you're focusing on the correct angle for this information. Cosine A is 3/4 on my example. Remember, cosine is A over H. That's the ka in SohCahToa, right? So that means my A adjacent, okay, to A is 3. My hypotenuse is 4. Now, before you go solving for this here, go to the next part and let's see what they want. We might not need to find it, okay? They want sine of C, okay? So the sine of C, sine is so in SohCahToa, so it is O over H. We know our H. That H isn't going to change, okay? Hypotenuse stays the same, all right? Now let's look at C. I'm going to put 2 tick marks, but just so we can visualize here. We know our hypotenuse, our opposite is what we need. Well, it turns out opposite is right over here. That is the 3. And that gives us our answer, okay? Your numbers are a little different, but it's the same process. Make sure you are drawing this out or at least writing out the thought process. Don't just give me the answer. Thank you. Number 2, if cosine theta equals 7/10, what is sine theta? So we're going to discuss this in class as well, but theta is just a symbol. It's a Greek letter. It's used to represent angles when you're doing geometry, trigonometry. So cosine and sine is what we're talking about here. We know we have to have a right triangle. We know that because cosine and sine only deal with right triangles. So just like in number 1, we're just going to draw a generic triangle, okay, that has a right angle in it. We know that we have an angle called theta. It doesn't matter which place you put it, okay? I'm just going to pick up here. That's just where I'm going to pick. If you put it down here, you could still do the problem, all right? So cosine of theta is 7/10. Remember, I don't even want to write it there. Okay, cosine, remember cosine is adjacent over hypotenuse, okay? So cosine of theta, adjacent hypotenuse, adjacent to theta is this one right here. This is the one it touches, so this is a 7. Hypotenuse across from the 90 is 10, okay? Now they're asking, what is the sine of theta? Well, sine opposite over hypotenuse, remember SohCahToa. So what they are asking us for is what is opposite of theta. Okay, we don't know what this is. I'm going to call it x. You can call it x, you can call it a, you can call it Steve. I don't care what you call it, just as long as you know we don't know it. Okay? Sine then of theta opposite, okay, is x over our hypotenuse, 10. So let's figure out what that x is equal to. Okay? If you have two parts of a right triangle, you can use the Pythagorean theorem. Okay? So I have 7 and x as my a and b. Does not matter which order you put them in. Okay, for the Pythagorean equals 10 squared. So I have 49 plus x squared equals 100. Subtract 49 from both sides, and I get x squared equals 51. I don't know if you can see that because the way the screen is. Let me rewrite it. That means we have to take the square root of both sides. X is the square root of 51. I cannot break that down any further, so it is just the square root of 51. That makes my answer the square root of 51 over 10. You do not have to simplify that any further. You don't have to use a calculator to get a decimal. You just leave it as is. And let me check your answer to see if you do have to reduce anything. Nope, yours comes out really nicely. You won't have to reduce anything. Number 3. On number 3, they give you a real-world problem. They show you a ladder leaning up against a building. They give you the angle, okay, right here between the ladder and the ground. It is a right triangle because the ground and building come at a 90-degree angle, which is pretty usual, right? And they're asking you to find the height over here. I changed mine. I'm going to find the ground length between the ladder and the building. So on yours, you're finding height and you have different numbers. On mine, I am looking for this length here. I'm going to call it x. Okay, again, you can call it a question mark, x, h, whatever you want to call it. On yours, that's fine as long as you know it's an unknown. So let's look at the pieces of this puzzle that we have. We have the 70. We know it's a right angle. If I look at this angle, what's adjacent to it is right here. What's opposite would be over here, which is what you're looking for, okay? But I'm looking for my adjacent, and I have my hypotenuse, so do you. Okay, which means for me, adjacent hypotenuse, I am using cosine. Okay, so cosine of 70 degrees is equal to x divided by 15. Now I need to solve this for x. X is the what length that we are looking for. To get x by itself, I need to multiply 15 on both sides. I get 15 cosine 70 degrees. Those cancel out. That's why we multiplied by it, is equal to x. This is my answer. Now you're not used to having an answer that looks like this that has cosine in it, but this is your answer. In the future, we'll look into how to put that into a calculator and get an actual degree measurement. Okay? Actually, in this case, it would be degrees. We would get an actual length measurement. But for your purposes on the EOC and for this assignment, you will leave it just like that. Number 4, they give you a right triangle and they give you some information to go with it. They say one of your lengths is 14, you have a theta as one of your angles, and they give you a trig function is equal to a certain amount. Of course, mine's a little different, as always. Cosine of 7/10. Remember, cosine is adjacent over hypotenuse. So they're telling us the adjacent is going to be a 7, the hypotenuse 10. But wait, they already said that's 14. How can it be both? Well, what they did is they have reduced this fraction to its lowest form. So essentially we're working with a ratio here. Imagine if you found a cosine theta that was equal to, let me make something up, 2/4. You could reduce that 2/4 to 1/2, and that's essentially what they did. So we gotta go backwards on it. What we're gonna ask ourselves is 7 times what is 14? Well, it's 7 times 2. So we're going to do the same here to our hypotenuse and multiply by 2. Okay? So our legs are 14 and 20, and we don't know. We need to find it. Here we're going to use the Pythagorean theorem. If you know 2 legs and you're looking for the third of a right triangle, that's what you're going to do. So we have 14 squared plus x squared is equal to 20 squared. That's 196 plus x squared equals 400. Subtract 196 from both sides. And we get x squared is equal to, I gotta do a little math. You remember, I could do it in my head, I don't feel like it. 903.2. X squared equals 204. Take the square root of both sides, and we get x is equal to root of 204. Now, we can't leave that as the square root of 204. We need to reduce that if we can. So we're going to see if there's any perfect squares in the square root of 204. You should remember back in algebra, covering this, we want to find something that's a perfect square that goes into 204 times something else. Well, I'm going to pick 4. Let's see if that can go into it. I'm pretty sure it can. So we divide 204 by 4, and we get 51. Okay? 51 does not have any perfect squares that go into it. Okay? So we can't go any further with that. So we're just going to come down. The square root of 4 is 2, and then the square root of 51. That is our answer for x. Number 5. Number 5 is a hard one for me to make an example to go with it because it's a little bit more theoretical. So I'm going to lead you in the right direction and then let you kind of make that final answer on your own. Sine A equals cosine A, which statement is true? So let's just draw a right triangle. I know we don't know exactly what it looks like, and that's okay. So basic right triangle with 90-degree angle, okay? Sine of A, well, let's see here. Let's just say ABC like we've been doing, okay? We'll call this A. The sine of A is equal to the cosine of A, okay? So our opposite over hypotenuse is equal to our adjacent over hypotenuse, okay? Remember, sine, cosine. So what we're saying here is these are equal to one another. I'm going to kind of let you figure out the rest. But what you could look at is the fact that this and this are equal, and this always stays the same. Huge hint, read through your answer choices, and you should come up with the correct answer.